9.3 is on page 621, talks about representing relations. A relation between finite sets can be represented by using zeros and ones matrix. So a 0 and 1 matrix. Suppose that R is a relation from A to B. Hence, the elements of the set A and B have been listed in a particular but arbitrary order. Furthermore, when A equal B, we use the same ordering for A and B. The relation R can be represented by a matrix with relation R given by Mij, where if A sub I, B sub j, where A is from set A and B sub j is from set B, are in this relation, we use a 1. If it's not, we use a 0. And I have an example on this, of course. Now, one thing about a matrix, this is row 1, this is row 2, this is row 3. This is column 1, column 2, column 3, and so on. So I made a list of what the location is. This is 1, 1. So this is row 1. You notice all of those are 1, all of those are 1, all of those are 1. This is the first column, second column, third column. So that's how it works. Sort of like an X and Y, but instead of Y being up and down, Y moves to the right column or not. 2, 2, 3, 3. This is 3, 1. So this is row 3, column 1. So let me start with an example to make sure you get this so we could really get this going. Suppose, and this is an example in the book, this is example 1 in the book actually. Suppose that A consists of 3 elements, B consists of 2 elements. Let R be a relation from A to B. If we're talking about M sub R, since this is 3 by 2, so we're going to have three elements in the first and 2 elements in the rows. There you go. That is 1, that is 2, that is 3, and that is 1, that is 2. And kind of like cross however those fit. So, and this is what it says. The relationship R contains the point AB if A belongs to A, B belongs to B, and A is bigger than B. So if I list all the elements that could happen, 1, 1, 1, 2, 2, 1, 2, 2, or 3, 1, and 3, 2. This would be all the possible relations you could have. Right now, what's the condition? An element is in this relation if A is bigger than B, where A is the first. A is equal to B, that doesn't count. A is less than B, that doesn't count. 2, 1, this is bigger. This, they're equal. It has to be bigger. That's what that says. 3 is bigger than 1, and 3 is bigger than 2. That's simple. So let's look at another example. Since we started this, represent each of the following relations, 1, 2, 3, 4, with a matrix with the elements of this set listed in increasing order. Okay, let's see what this means. So the elements are 1, 2, 3, 4. They want us to list the following conditions. So 1, 2, and 3. 2, 3, 4. So we need 4 of those. 1, 2, 3, 4. That's how this is gonna look. You know what? Let me not list those because that makes things a bit messier. Here, let's just go by, since we have 4 of those. Here, let's go this way. So, do you notice 1, 1 is not there? 2, 1 is not there. 3, 1 is not there. 4, 1 is not there. Or actually, let's go this way. Let's go this way. 1, 2, 1, 3, and 1, 4. There is no 2, 1. There is no 2, 2. There is a 2, 3, and a 2, 4. There's no 3, 1, no 3, 2, no 3, 3, but there is a 3, 4. And there's nothing in row 4. And there it is. How about the following relation? 1, 1, 1, 2, 1, 3, 1, 4. 2, 1, 2, 2, 2, 3, 2, 4. 3, 1, 3, 2, 3, 3, 3, 4. 4, oops, 4, 1. 4, 2, 4, 3, 4, 4. There. Fairly simple. Make sure you get that out of the way. How about this one? 1, 1, 1, 2, 1, 3, 1, 4. 2, 1, 2, 2, 2, 3. I'm sorry, there's no 2, 2. 2, 2, 2, 3, 2, 4. 3, 1, 3, 2. 3, 4, there's no 3, 3. 4, 1, 4, 2, 4, 3. How about this relation? Sorry about that. That's what I meant to do. My mistake. 1, 1, 1, 2, 1, 3, 1, 4. 2, 1, 2, 2, 2, 3, 2, 4. 3, 1, 3, 2, 3, 3, there's none. 3, 4, 4, 1, 4, 2, 4, 3, and 4, 4. So hopefully I didn't make a mistake, and if I did, hopefully we get how this works. Can I go backwards? Again, this is extremely important for what's to come. List the order first. Again, 1, 2, 3, 4. This is 1, 1, 1, 2, no 1, 3, 1, 4. And this is 2, 1, no 2, 2, 2, 3, no 2, 4. 3, 1, no 3, 2, 3, 3, and 3, 4. And 4, 1, 4, 3, and 4, 4. There we go. Done. And how about this relation? 1, 1, 1, 2, 1, 3. That's it. 2, 2. That's it. 3, 1, 2, 3, 3, and 3, 4. And 4, 1, and 4, 4. And this is 1, 1, excuse me. So this is 1, 2, and 1, 4. And this is 2, 1, and 2, 3. And this is 3, 1, and 3, 3, 1, no, 3, 2, 3, 4. And 4, 1, and 4, 3. And hopefully, again, I didn't mess up on those. I'm checking my work. All right. How about the following relation? These are the two matrices we have. It says R1, R2 are given by the following rate. This is R1, R2. What do you think R1 and R2 means? Well, if you take this, this is a 3 by 3. This is the union, if you remember, right? So the union, 0, 0, okay, that's 0. 1, 1, well, that's 1. That's a 0. 1 or 0 is a 1. 1, 1 automatically. I don't need to see the other one. This is a 1 for sure. 0, 1, well, those are 1, so it's positive because it's union, right? It's really simple. Intersection, you want them both to be the same. Now you got to look at both. So 0, 1, 0. Since those don't match, that's a 0, but these are 1s, so those match. 1, 1, and those two don't match with that. Those are both zeros. Remember this one, it's like one or the other, kind of like saying you could take A or B. Either you take A or you can't take both. So they can't match. They're both 0 in this case, that's unacceptable. They're both 1, that's unacceptable. They're both 0, that's unacceptable. But when I get to the second part, I notice that 1 is on, 1 is off, that's acceptable. Those are the same, they can't be. This is the same, that can be, but those two here are one or the other, they're both acceptable. So again, it's one or the other, not both. Now comes the last part, a really important part for us in this class. Draw the directed graphs representing each relation as an exercise 1. So 1, 2, 3. There is 1. This is A. You know what? Here. Let's go this route. This is 1. This is 2. And this is 3. So I glance at this before I start. You can do this a few ways. 1 goes to 1. That's easy. 1 goes to 2 and 1 goes to 3. 1 goes to 2 and 1 would go to 3. So if it's only going in one direction, you just put an arrow. You could make it like curvy line, but there's no need to. B, I have 1, 2, and 3 again, the same deal. I'm going to go 1, 2, 3. And actually, here, let's go this way. 1, 2, 3, so it doesn't get in the way. I notice 1 goes to 2 and 2 goes to 1. So instead of putting a line, that's how we show it. 2 goes to 2, 2 goes to itself, and 3 goes to 3. There we go, done. Really simple. 1, 2, 1, 2, 3, 1, 2, and 3 again. So again, 1, put it out of the way so it doesn't get in the path. 1 goes to 1. That's easy. 1 goes to 2 and 1 goes to 3. 1 goes to 2 and 1 goes to 3. Now 1 goes to 3, but 3 doesn't go to 1. There we go. The arrow should be in the middle. Okay, 2 goes to itself. 2 goes to 3 and 3 goes to itself. 2 will go to 3 and 3 will run to itself. By the way, when you go, a 3 goes to itself, that's like when you hit refresh on your website. You ask it to reload itself. That's what that means. And here we have only 1 and 3. So 1, if I want to list 2, I can, but there's no 2. And let's say I list 3 right there. 1 runs to 2 and 1 turns to 3 and 3 runs to 1. There. So those are very important for what's to come. Make sure that you get those out of the way. Same deal here. If I wanted to really play this out, draw the line representing these in example 3. This is 1, 2, and 3. So let's go again. Here's 1. Here's 2. And here's 3. 1 runs to itself. 1 runs to 3. And I notice 3 runs to 1. So I just did those 3. 2 runs to itself. And 3 runs to 1. Or 1 runs to 3. 3 runs to itself. There we go. And that's pretty much it for that one. If I want to go for 1, 2, and 3, I notice here that this is 1 runs to 2, 2 runs to itself, and 3 runs to 2. And if I want to look at that one right there again, there's 1, there's 2, there's 3. 1 runs to 1, 1 runs to 2, and 2 runs to 1. 1 runs to 3, and 3 runs to 1. 2 runs to 3, and 3 runs to 2, and 3 runs to itself. There it is. 22. Draw A, B, C, D. Well, let's see. A. You could do this in any order. A, B, C, D. A runs to itself. A runs to B. B runs to C. C runs to B. C runs to D. D runs to A. And D runs to B. There we go. And can I list what this is saying? This says A runs to itself, A runs to itself, A runs to C. A is done. We could go to B. B runs to itself, and B runs to A, and B runs to C. C runs to itself, C runs, and that's it. A runs to itself. It seems A runs to B. A is done. B runs to itself, and B runs to A. That's it. C runs to itself, C runs to A, and C runs to D, and D runs to itself. 28, last problem we have. A runs to itself, A is running to B. Again, it's right there. B runs to itself, and B is running to A. And here, C runs to itself, C runs to D, D runs to itself, and D runs to C. And that's pretty much it for this section.